Here's a quick video on the halogens. We're going to break it into two parts: terms, electronegativity, boiling points, oxidizing agent, displacement reactions. So terms are focusing on molecule, atom, and ion. So molecule, for example, fluorine F2, note the spelling. Atom, BF or BR or Cl or I, and the halide ion, F minus, so for example fluoride. So it's important you know the difference between halogen and halide. And then electronegativity. So electronegativity definition is the ability of an atom to draw a shared pair of electrons towards itself in a covalent bond. Now fluorine has the greatest electronegativity of all of the atoms. This is because it's the smallest atom. Its nucleus is closest to the shared pair of electrons, so it can attract those electrons so strongly, and it's also really small, so it's got the least shielding between the nucleus and the shared electron pair. The boiling points: all the halogens are simple molecules, and they're all non-polar because they're just diatomic of the same atom. Because they're simple molecules, they have intermolecular forces, and because they're non-polar, they only have van der Waals between molecules. Now iodine is the greatest MR. It's got the most electrons, therefore it's got the strongest van der Waals intermolecular forces of the halogens, and therefore it's got the highest boiling point because it requires the most energy to break those intermolecular forces. Halogens as oxidizing agents. First off, the definition. So definition of an oxidizing agent is it gains electrons. An example of a molecule like fluorine gaining electrons is F2 plus 2E minus goes to 2F minus. You can see it's gain electrons. That's called a half equation. And then fluorine is the strongest oxidizing agent of the halogens. It's got the smallest atomic radius. It's got the least shielding, and therefore it tracks electrons most readily. And I've got a little picture at the bottom, and you can see electrons would be attracted to the nucleus of the really small atom in the fluorine molecule, and the iodine atoms are much bigger, so they would attract the electrons much less. And finally, we've got displacement reactions, which links to oxidizing agents and oxidizing ability. So halogens, further up the group, displace halide further down the group. So fluorine will displace all of the halides, chloride, bromide and I minus. And chlorine will displace bromide and iodide, and bromine will displace iodide only. So what is displacement? Here we've got an example of that. So chlorine plus sodium bromide. The sodium bromide will be an aqueous solution, so everything's dissolved in water. There's a displacement reaction, so you get 2 sodium chloride, aqueous, and then bromine, aqueous as well. So you can see the chlorine has displaced the bromide from its sodium salt, and you've got an ionic equation there as well below that. So chlorine reacts with 2Br minus, forms 2 chlorides, and then bromine as the product, and a yellow solution is formed. That finishes this first video. Next we're moving on to halogens part 2.